Hello guys, I'll be teaching Form 5 Maths Chapter 2 Matrix by SPM Maths Poster. So there's two parts, which is 2.1 and 2.2. 2.1 is matrix, 2.2 is basic operation of matrix. Let me introduce you to 2.1 part first. A matrix is a set of numbers arranged in rows and columns to form a rectangular or a square array. A matrix is usually represented with capital letter and written in the bracket, this bracket, or this bracket. Like for example, this and this is a matrix represented using this bracket and this bracket. It's two type bracket. The next rows, column, and order of matrix. So here's the matrix, and this is called row, and it's row 1. And row 2, if there's another row, is called row 3. Then it's column 1, column 2, and column 3. And matrix with n rows and n column has the order m times n, and is read as matrix m by n. So for this one, there's 2 row and 3 column, so it's 2 times 3. And row matrix is a matrix which has only 1 row. So there's some example: 1 times 1, 1 times 2, 1 times 4 means that 1 row. And the next one is column matrix, is a matrix which has only 1 column. And 1 times 1, 2 times 1, 4 times 1, the column is all 1 because it's only 1 column. And square matrix is a matrix which has equal number of rows and columns. Number of rows equals to number of columns. So this one is 1 times 1, 2 times 2, 3 times 3, there's 4 times 4, and 5 times 5, and more on. That's why it's identify certain elements in a matrix. So this is an example. A and ij will represent with numbers, but in this I means which row, j means which column. So let's an example. So for this one, first one is mean row, second one is column. So this means second column and first row, which is 9. Second one is first row and first column, which is 5. Then first row, third column, which is 0. And then second row, second column, second row, second column. And then first row, second column, first row, second column, which is 3. And then second row, third column, which is 7. So, and for equal matrix, two matrices are equal if they have the same order and their corresponding elements are equal. So it's 2 times 2, and it's also 2 times 2. So A is equal to 6 since they are equal matrix. So B is equal to 2, C is equal to 5, A is equal to 3. And then there's an example. Determine whether the following pairs of matrices are equal. So for A, it's equal because order of matrix C. And for the first one is 2, second one is 5, so it's equal. For B, obviously not equal. Order of matrix is different. This is 3 times 2, this is 2 times 3. And then for C, it's not equal to, because the first one is correct, 3 is 3. But 6 is not equal to 9. But others are the same. But also, it's not an equal matrix since there's 1, it's not same. And state the value of the unknowns in the following pairs of equal matrix. Find x and y. So this 2 times 1 matrix is also, so we just take the first one, first row, first column. So y equals to 10, y equals to 10 divided by 2, y equals to 5. And then x plus 5 equals to 20. So x is equals to 20 minus 5, show the 5 to opposite side. And then x equals to 50. So we have finished our 2.1. Let's get into our 2.2, basic operation on matrix. So, addition and subtraction of matrix, if both matrices have the same order, only can be added or subtracted. For example 1, A and B, let's see, can we add or subtract? Determine the following matrix can be added or subtracted. If yes, determine the value of the addition and subtracted. If no, just give a reason for it. A is no, because obviously the order of matrices are not equal, so we cannot add or subtract it. So for B, it's square matrix, so we can add or subtract together because the order of matrices are equal. So this answer for if we subtract together, not subtract, sorry, if we add together. So this is the answer if we add together. So 7 plus 4, 6 plus 2, 1 plus 9, 3 plus 5. Add together we get 11, 8, 10, 8. And then if we subtract, also same. So 7 minus 4, 6 minus 2, 1 minus 9, 3 minus 5. So the answer is 3, 4, negative 8, negative 2. There's another example for it. Given that this matrix and this matrix equals to this matrix, find the value of A and B is equal to 2A, 6, AB, 80, 5 plus 2B. So first we add these two matrices together first because the order of matrix is the same, so we can add it together. So 2A plus A, 6 plus B. And then we take it out. 2A plus A equals 18. So 2A plus A equals 3A is equals to 18. We let the 3 do the opposite, which is A equals to 18 divided by 3. So A is 6. Then another one is 6 plus B equals to 5 plus 2B. 6 minus 5 equals to 2B minus B. 1 is equals to B. So I just switch the place to be nicer. B is equals to 1, A is equals to 6. Multiplication of a matrix by a number. When a matrix is multiplied by a number, every element in the matrix is multiplied by the number. So for this one, every element need to multiply with 2. So 2 times 4, 2 times 7, 2 times 2, 2 times 9, times together we get 8, 14, 4, 18. Next, two matrices can be multiplied when the number of columns for the first matrix is the same as the number of rows for the second matrix. So if first matrix and second matrix first matrix column number and second matrix number of row is same, we only can multiply together and we only take the first one, the last one, which is the row number of row for first matrix and number of column for second matrix. So it's n times O. So we just m for this one is called order of the product. This sixth example, and for A, 1 times 2, 2 times 1, we can see that the number of column of first matrix and number of row for second matrix is same, so we can multiply together. For another 5 also same, you can see that the first order of matrix, the column, and second order of matrix, the row is same, so that we can multiply together and get the order of the product. And for A is A times B, B times D, and plus it together, because we'll get one number at here. For B is 2 times 2, 2 times 1, so we just take 2 times 1. So A times E plus B times F. For second row also, C times E plus D times F. And C is A times E plus B times G. And another one is A times F plus B times H. C times A, E plus D times G. C times F plus D times H. 2 times 2. And D is 2 times 1, 1 times 2. So we just take 2 times 2. And for this one, we know to add A times C, A times D, B times C, B times D. E is 1 times 3, 3 times 1. So we just take 1 times 1 because we can multiply together since the first metric column and second metric row is the same. So right now we'll get 1 times 1 only. So it's 1 times D plus B times E plus C times F. And F is 3 times 2, 2 times 1. So right now we'll get 3 times 1 only. So it's E times 3 plus B times H. And then another row is C times G plus D times H. The last row is E times G plus F times H. So these are all the examples. You can screenshot and save it. And next slide. There's for some examples. Determine the following matrix can be multiplied and state the order of the product. Calculate the answer if it can be multiplied. So A is 2 times 1 and then 2 times 2. So the first one is 2 times 1, 2 times 2. So the first matrix number of columns is not equals to second matrix number of rows, so it cannot be multiplied. And B is 2 times 2 and 2 times 1. So this one we can multiply together since the first matrix number of column and second matrix number of rows is same. And the order of product is 2 times 1. and C is 1 times 2, 2 times 1. The number of column for first matrix and number of row second matrix is same. So we can multiply together. And the order of product is 1 times 1. Next, let us calculate the number. So since this product 2 times 1, so 4 times 1, 9 times 6. Then 2 times 1 plus 4 times 6. We just multiply together and then add together and then you get 58 and 26 is answer. And for another one, see, you get 1 times 1 for this answer. 4 times 7 plus 3 times 5. Just times together and then add together and we'll get this answer, which is 43. Next, identify matrix. When 1 is multiplied with any number, A, for example, is A, its product is A. When A matrix is multiplied with matrix A, its product is matrix A. A times 1 is equals to A. 1 times A is equals to A. Identify matrix is a square matrix. It denoted by the letter I. So when you saw I, the letter I is mean identify matrix. All the diagonal elements from top left to bottom right of an identity matrix are 1 and the rest of the element are 0. Top left is here and bottom right is 0. So here and here is 1 and the rest is 0. And if I is the identity matrix of order n times n and A is a matrix of the same order, then IA equals to A and AI equals to A, which means if the identify matrix times the matrix is equal to A, matrix A, then if matrix A times identify matrix is also equal to A, matrix A. So let's get through with some example. Determine whether each of the following is identity matrix of this matrix for 8, 2, 6. So there's 2 identity matrix. You don't need to true, so we just times together. This times together, this is 2 times 2, 2 times 2. So end up you get 2 times 2 matrix for the answer. So just 4 times 0 plus 8 times 1, 4 times 1 plus 8 plus 8 times 0. And then 2 times 0 plus 6 times 1. And then 2 times 1 plus 6 times 0. And then I just times together and then plus together, and I will get 8462. 8462 is not answer same with the original one. So this one, 0110 is not an identity matrix. So let's see B. We also say 4 times 1 plus 8 times 0, 4 times 0 plus 8 times 1. And then 2 times 0 plus 6 times 0. And next 4 times 1 plus 8 times 0. 4 times 0 plus 8 times 1. 2 times 1 plus 6 times 0, 2 times 0 plus 6 times 1, and we times together and then add together, and then we get 4826, which is the same as the answer. So this one is matrix 1001 is an identity matrix. And then next is inverse matrix. If A is a square matrix, B is another square matrix, and A times B equals to B times A equals to identity matrix, and matrix A is the inverse matrix of matrix B, and vice versa. Matrix A is called the inverse matrix of B for multiplication and vice versa. Symbol A or -1 denotes the inverse matrix of A. Inverse matrix can only exist for square matrix, but not all square matrix have inverse matrix. If AB not equals to identical matrix or BA not equals to identical matrix, then A is not the inverse of B and B is not the inverse of A. X is an inverse matrix example. Tell me whether the following matrix is inverse matrix of 7, -3, 5, -2. So there's A and B. So let's see the answer first. Use times together with this matrix and this matrix. So 5 times 7 plus 2 times 5. Another one is 5 times -3 plus 2 times -2. And then 1 times 7 plus -7 times 5. 1 times -3, 1 so -7 times -2. And then times together, add or minus together, and then we will get this matrix. So this matrix 5, 2, 1, -7 is not the inverse of matrix. I miss out the matrix this one because the product of 7, -3, 5, -2, these two matrices is not an identity matrix. Let's see B. Too fast. So B times these two matrices together too. So same times together. I skip this part. Just times together, and then add together, and then you get the answer, which is 1, 0, 0, 1. If what else if we switch these two matrices and times again? So we times together and then plus together, and then we also get 1, 0, 0, 1. So negative 2, 3, negative 5, 7. This matrix is the inverse matrix of this matrix because the product of these two matrices is an identity matrix. This type is AN. And then next, the inverse matrix of a matrix may also be found using a formula. If A is ABCD, then the inverse matrix of A is A minus 1 is given by the formula below. A minus 1, which is inverse matrix of A, is equal to 1 over AB minus BC. And inside also change. A and D switch place, and then we pass my negative to B and C. So it's negative B and negative C, where A minus BC cannot be equals to 0. And A minus BC is known as the determinant of matrix A. If the determinant AD minus BC is equals to 0, then the inverse matrix of A does not exist. So let's see some example. The inverse matrix of this matrix, negative 3, negative 6, 2, 5, is this matrix is a bit say A and then inside got B and C. So find the value of A, B, and C. So we just find the inverse matrix of this matrix, so we auto will find the answer. So here's the answer. So 1 over is AD minus BC, so AD, so negative 3 times 5 minus BC, which is negative 6 times 2. We don't take this part. The ABCD is from here, not here. And then for here, we just switch 5 and negative 3 place, switch place. And then for BC, we need to add negative. So if there's negative, negative is positive. So negative 6 times negative is positive 6. And then 2 we times minus negative. So it's like negative 2. And then next we just times together. And then minus together for the inside matrix part is still remain the same. So right now we look at negative 1 over 3 and 5, 6, 5, 6, negative 2, negative 3. So now we can compare and find A, B, C, D. A is equal to negative 1 over 3, B is equal to 5, and C is equal to negative 3. So, and solving simultaneous linear equation using matrix. For example, two simultaneous linear equation can be written in the matrix equation form. For example, is AX plus BY equals P, CX plus DY equals to Q. Matrix form AX equals B is like this, and where A, B, C, D, P, and Q are constant, while X and Y are unknowns. So, this one as an explanation. At first, AX equals to B, which is this, and we need to remove the matrix A. So both sides we add inverse matrix, and then the inverse matrix times matrix equals to identity matrix, which is the 1, 1, 0, 0, 1, that matrix. And here still remain the inverse matrix. So the answer is X equals to inverse matrix and B. So it's look like this. And we go into the example, we understand more. So let's go into the example for this. Solve the following simultaneous equation by using matrix method. So here's x minus y equals to 7, x plus 3y equals to 5. And if we write in the ax equals to b form, so it's for x is 1, and then for y is negative 1. Here's, if here is positive, so here's just equals to 1. Here's negative, so we just add the negative together with the y, and then x, there's no number, so it's 1, and 3y is 3, and xy is 7 and 5 is the formula. And then let A equals to the matrix A 1 and 1, 1, 3. We find the inverse matrix first. So the inverse matrix formulas here. So 1 divided by 1 times 3 AD minus BC, which is negative 1 times 1. And here we have a change. So AD, here's A, I typo. AD we switch place. So 1 becomes 3, 3 becomes 1. And then for BC we add minus on it. So originally is negative 1. So negative positive, so it's become positive 1. And then here's 1, so here will become negative 1. And we just times together and minus together, and now we'll get 1 over 4. and the matrix is still remain the same. And the next step is skip the part which we need to just like we need to add the inverse matrix here and skip here, and then I just put the inverse matrix inside this, and then we need to times these two matrices together. Here is 2 times 2 and 2 times 1, which we can times together. So 3 times 7 plus 1 times 5 and negative 1 times 7 plus 1 times 5. So we times it together and then add together, and up we'll get this number 26 and negative 2. And then we need to times the 1 over 2 inside, so which is 26 over 4 negative over 4. We times inside and we make it more simple. And then small x is equals to 13 over 2, y is equals to negative 1 over 2. So we have finished 2.1 and 2.2, and next we are going to enter some extra exercise. So exercise 1 is about multiplication, addition, subtraction. So here's A, B, C, and there's A and B. You can stop the video and do it yourself first, and then come back and check your answer. So for question number A, here's the answer. It's A times 2B. So we take the matrix A plus we put 2 outside because we need 2 times with 2 with matrix B. So first we times the 2 inside first. 2 times 5, 2 times 7, 2 times 4, 2 times 4 times together, and then we get 10, 14, 8, 4. And then we only add together. So 3 plus 10, 1 plus 14, 6 plus 8, 8 plus 4. Add it together, and then we'll get this answer. 13, 15, 14, and 12. And we get 3A minus B, which is 3 times matrix A minus matrix B. Goes to, we times inside first, only subtract. So 3 times 3, 3 times 1, 3 times 6, 3 times 8, and then the matrix B will just remain the same. We just settle down the multiply first, and then we get 9, 3, 18, 24. And then we only subtract together. So 9 minus 5, 3 minus 7, 18 minus 4, and 4 minus 2. And now we'll get answer 4, negative 4, 14, and 22. And C is multiplication, which is A and B. So we just take now matrix A and B multiply together. So for this 2 is, so it's 2 times 2, 2 row, 2 column. So also 2 row, 2 column. So end up with 2 times 2 matrix 2. So it's 2 row, 2 column. So we just time together 3 times 5, 1 plus 1 times 4, and another one is 3 times 7 plus 1 times 2, and then 6 times 5 plus 8 times 4, and then 6 times 7 plus 8 times 2. Just times together, and then we add together, and now we'll get this answer 19, 23, 62, 52, 58, sorry, it's 50. I messed up. And that's for exercise 1. Let's go to exercise 2. Find the answer above. These all are multiplication. And you may stop the video and do it yourself first when we come back. Let's go for question number 8. So question A is here, right? 1 times 3. The order is 3 times 2. So since these two is the same, so we can multiply together. So and then we get 1 times 2. And then it will be like negative this whole row times with this whole column. And then this whole row times with this whole column again. So it's negative 1 times 3, 2 times 2, 1 times 1, plus together. And then another one is negative 1 times 4, 2 times 5, 1 times 6, and then plus together 2. And then end up use times together and then add together, and then we'll get 2 and 12 answer. And question number B is 3 times 2 and then 2 times 1. So obviously we can multiply together, and the order of the product is 3 times 1. So it's saying 8 times 1 plus 6 times 3, 5 times 1 plus 4 times 3, 2 times 1 plus 3 times 3 times together, and then end up add together. Let's skip the explanation because it's easy. So I straight away skip to the answer. It's 26, 17, 11 for the answer. And then there's C is negative 2. 1, 5, 3, 4, 2 is 2 times 2 and 2 times 1. So obviously we also can multiply together, and now we'll get the order of the products 2 times 1. So it's negative 2 times 4 plus 1 times 2, and 8 times 4 plus 3 times 2. And times together, add together, and that will get the answer negative 6 and 36. If any answer is wrong, you can just comment that below. I might be calculate wrong too, sorry. And next, exercise 3. So A is find the inverse matrix of this matrix 3, 2, 5, 4. And B, Joyce and Alice went to the supermarket to buy potatoes and onions. Joyce bought 3 potatoes and 2 onions for RM9 ringgit, RM9. And then Alice bought 5 potatoes and 4 onions for 16 ringgit. By using matrix method, find the price in RM of a potato and the price of an onion. Grammar error, sorry. So A, we just find the inverse matrix first. So hope you all still remember the formula is 1 over AD minus BC. And then for the bracket inside is D minus B minus C and A. So here AD, A is 3, B, D is 4, minus BC, B is 2, C is 5. And then here's D, D is 4. And here's A is 3, we switch the place. And then BC equals to negative B negative C. So we add negative since there's no negative here, so we just add on. And then times together, end up you get 1 over 2 for the fraction, and then the bracket still remain in C. If you can just times inside to the matrix 2, so end up you get this answer 2, negative 1, negative 5, 2, and 3 over 2. And this is for question A. That's question B. Sorry, this answer is big. Yeah. So we use potato as x, onion as y. So if we write linear equation is plus 3 potatoes, which is 3x, which is x. So 2 onion, 2 y is equal to 9. And then 5 potato, 5x, and 4 onions, 4y equals to 60. So this is a linear equation, and we write to ax equals to b. So we can just straight away take this inverse matrix since it's C, 3, 2, 5, 4, 3, 2, 5, 4. So we just use the inverse matrix and put it on here. And then we just times together 2 times 9 and plus negative 1 times 16. And then this fraction times 9 and plus this fraction times 16. And then just times together and add together. And now you get 2, 3 over 2. And x is equals to 2, y is equals to 3 over 2. If, for example, the 1 over 2, you want to times inside is okay too, because now we also get the same answer. And so for price of a potato is equals to 2, and price of an onion equals to 1.5 RM. RM 1.5, sorry. And next, exercise 4. In August, a supermarket sold 48 bath towels and 45 bottles of bath soap with a total sales of RM 1389. In September, the supermarket sold 50 bath towels and 62 bottles of bath soap with a total sales of RM 1704. Using matrix method, find the price of a bath towel and a bottle of bath soap. So I use towel as x and soap as y. So here's the 48x plus 45 soap, which is y, 45y equals 1389. And then another equation is 50 towels 50x plus 62y, so goes to 1704. So okay, sorry, this is the matrix ax equals to b. So it's 48, 45, 50, 62, and then xy is equals to 1389 on 704. Next we just take these matrices. So it's 1 over, here's the measure, AD minus BC. So 48 times 62 minus 45 times 50. So times together, and then here 62 and 48. We just switch place. And then BC we not plus, we times minus negative together. So it's negative 45 and 50. So it's 1 over 2956 minus 2050. And then here is still remaining same. And then the answer is 1 over 726. And here's the same, but we times the fraction inside each of the element. So end up the answer is this. And next, we just use this inverse matrix and put inside. So we times this fraction times this number plus this fraction times this number. So it's a bit long, a bit hard to say, so I just use this fraction times this number times plus this fraction times with this number. So we just times together and then plus together, times together, plus together. End up you get 13 for this, and then another one is 17. So x is equals to 13 and y is equals to 17. So the price of a beef tower is equals to RM13, and price of a quarter for beef soup is equals to RM17. So that's all for my teaching. Thanks for watching. If you like our YouTube channel, just like and subscribe. Thank you.